Imagine, just for a moment, a world that's spinning faster than the one we know. Now, think about this. Instead of the familiar 24-hour cycle of day and night, the Earth spins so fast that a full day, a complete rotation of the planet, only takes 12 hours. Suddenly, time feels like it's moving quicker, the world is in perpetual motion, and nothing stays the same for long. What happens when everything we've built our lives around, the rhythms, the climates, the ecosystems, even the fundamental laws of physics, is suddenly thrown into fast forward? What are the consequences of doubling the speed at which the Earth spins? Would we be able to adapt? Or would we struggle to survive in a world that's moving too fast for us to keep up? Let's take a closer look, step by step, to understand what would happen if the Earth suddenly spun twice as fast. The idea of a faster spinning Earth isn't just a fun thought experiment. It's rooted in the very physics of angular momentum and centrifugal force. Right now, Earth completes one full rotation in 24 hours. But if we suddenly increased its speed, Earth would complete a full spin in just 12 hours. That's a change in momentum with profound consequences. You might wonder, what does this mean for the planet's shape? As Earth spins faster, its equatorial bulge would become more pronounced. The centrifugal force acting at the equator would push outward, creating a more oblate Earth, a globe that's more squished at the poles and wider at the equator. Imagine Earth's silhouette transforming from its familiar, slightly flattened sphere to something more egg-shaped. This centrifugal force would also affect gravity itself. At the equator, gravity would weaken because the centrifugal force is pushing outward, making it feel as though gravity is pulling less strongly than it does now. You might feel lighter near the equator, as if the pull of the Earth itself is weaker. However, this diminished gravity wouldn't just be an odd feeling. It could have far-reaching consequences for everything from human health to the behavior of the oceans. What happens to the Earth's oceans under these new conditions? As the centrifugal force increases, it will push water toward the equator, causing sea levels there to rise. The equatorial bulge of water could result in catastrophic flooding along coastal regions. Low-lying islands and cities at or near sea level, many of which already face threats from rising oceans, could become even more vulnerable. Entire populations could be displaced as the oceans claim land they've never known to be under threat. At the poles, however, the weaker centrifugal force would cause the oceans to recede. Imagine the Arctic and Antarctic regions facing drastic drops in sea level. The frozen ice sheets might shrink in response to this new gravitational pull, potentially opening up new land for exploration, but also creating environmental challenges we've never encountered before. The imbalance of water on Earth would completely alter ocean currents and global climate patterns, leading to a domino effect of unpredictable changes. In short, the rise of ocean waters at the equator and the fall of water at the poles could change the way we understand Earth's geography, flooding some regions and drying out others. The entire global hydrological cycle would be thrown into chaos. Now, let's talk about the most immediate and obvious change, the day and night cycle. Currently, the Earth rotates once every 24 hours, giving us a steady balance between light and darkness. The time it takes for the sun to rise, move across the sky, and set again is predictable, a constant rhythm we rely on. But what happens when the day is suddenly cut in half? A 12-hour cycle means that the sun will rise and set in a fraction of the time it does now. Days would feel much shorter, and nights would be half as long. This isn't just a minor shift. It's a fundamental change that could disrupt everything from our biological rhythms to how we organize our lives. Humans are creatures of habit, and our internal clocks, our circadian rhythms, are fine-tuned to a 24-hour cycle of light and darkness. If the Earth's rotation sped up, sleep patterns would be thrown off. Would we sleep for shorter periods, trying to adjust to the faster pace? Or would we struggle with chronic fatigue as our bodies try to adapt to the new, much quicker cycle? The effects on wildlife could be even more drastic. Animals that rely on a steady night for foraging or hunting could be thrown off balance. Species that depend on long periods of darkness, like nocturnal animals, might not have enough time to hunt or rest, disrupting ecosystems in unpredictable ways. Birds, bats, and insects that migrate or navigate by the stars might find themselves off course as the entire cycle of day and night compresses. For plants, photosynthesis might change dramatically. With only half the time to absorb sunlight, plants may not be able to produce the energy they need. Growing seasons would shorten, and agricultural practices would need to adapt to much quicker cycles of planting and harvesting. The effects on weather and climate would be nothing short of drastic. The faster the Earth spins, the stronger the Coriolis effect, the force that drives the rotation of air currents and ocean currents. With a quicker rotation, this force would intensify, which could supercharge storm systems. Hurricanes, tornadoes, and cyclones would become more frequent and more powerful, ravaging coastal areas and destabilizing already fragile environments. With only 12 hours of daylight, temperature fluctuations between day and night would become even more extreme. Regions that are typically warm might experience scorching heat during the shorter days, followed by frigid nights, creating a harsh, unpredictable environment. These temperature swings could wreak havoc on ecosystems and agriculture. Crops would wilt in the heat or freeze in the cold, leading to widespread famine in some regions. The global water cycle would shift dramatically as well. Faster rotation would lead to quicker shifts in wind patterns, altering how water moves through the atmosphere. Regions that rely on predictable monsoons or seasonal rains might experience erratic weather patterns, with rains coming too early, too late, or in devastating downpours. The changing weather would place additional strain on resources, creating challenges for societies everywhere. Life on Earth is incredibly resilient, but even the toughest species would be tested by such rapid changes. Some animals might evolve to become more active during shorter days, while others might go into hibernation during the nights, adapting to the intense fluctuations of light and dark. But evolution takes time, and not every species would survive such a rapid change. For humans, society would have to find new ways to live in a world with shorter days. We might need to adapt our sleep cycles, relying more heavily on artificial lighting to simulate the passage of time. Work hours might be compressed, and we'd likely need to embrace more flexible schedules to match the rhythm of a world that never stops. But would we be able to keep up with this relentless pace? Would mental health deteriorate in a society that is perpetually running faster than it can breathe? Sleep disorders, anxiety, and stress-related illnesses could become widespread as we try to adapt to an environment that demands more of us than we were built to handle. So could this really happen? Could the Earth's spin suddenly double in speed? It's incredibly unlikely, but not entirely impossible. A massive collision with an asteroid, a sudden gravitational interaction with another celestial body, or some unforeseen cosmic event could theoretically alter the Earth's spin. However, the consequences would be immediate and global. The changes would be so extreme, so profound, that our world, our entire existence, would be reshaped in ways we can barely begin to imagine.